Hello students, and welcome back once again to the online lectures over design of prestressed concrete structures through JCE Connect. Okay, so in today's session we are going to discuss the new chapter, that is Anchorage zone stress, that is Anchorage zone stresses in post tension beam. What is the anchorage zone stresses in post tension beam? So generally the anchorage is provided only in post tension beams. Okay, the anchorages are provided only in post tension beams. So we are going to find out, or we are going to discuss how the stresses are developed in the post tension beam due to anchoring of the cables. Okay, so that we are going to discuss today. So before going to that, we should know what is anchorage. So anchorage, I told you there are two types of beams in prestressed concrete. One is post tension beam, one more is pre-tensioned beam. Okay, pre-tension and post tension. So pre-tension, what is pre-tension beam? So in pre-tension beam, the tendons were passed through the section before pouring the concrete, or the tendons were passed through the section before pouring the concrete, and the tendons were stretched before pouring the concrete. In pre-tension section, what will happen? The tendons will be passed through the section and the tendons were tensioned or stretched before pouring concrete. So after pouring concrete, when the concrete reached the hardened stage, the tendons were released at the ends. Okay, so here no need to provide any anchorage system or any locking system, because the tendon is surrounded by concrete and the concrete itself lock the tendon. So no need to provide any anchorage. But in case of post tension beam sections or in the post tension construction, the ducts were provided into the beams. The ducts were provided into the beams, and after pouring the concrete, when the concrete reach hardened stage, the tendons will be passed through the ducts. The tendons will be passed through the ducts and it will be stretched. The tendons will be stretched, and if you release the tendon without locking or without anchoring, it will pass through again, it will go back to the original position, try to go back to the original position. So to avoid that, the tendons will be stretched and it will be locked or anchored at one side of the section. So that is called as anchorage. And what is anchorage zone now? What is anchorage zone? So it is a portion of the structure or a beam in which the concentrated pre-stressing force is transferred from anchorage device into the concrete. So what is that? It is a portion of a structure. Suppose we will take up a beam here. Okay, we will take up a beam. So you can see here we have a prestressed concrete beam here, and the tendon which is passed through the section, so which is a concentric. The tendon is passing through the centroid, so it is a concentric tendon, and we have the bearing plate here, which is at the end of the section and which is used to lock the tendon, This bearing plate is used to lock the tendon or to anchor the tendon. Then what will happen? This tendon will develop a pre-stressing force when the tendon is stretched. When the tendon is stretched and the anchor at the ends into the bearing plate, or by using this bearing plate, that tendon will develop a pre-stressing force P. That tendon will develop a pre-stressing force P, and that pre-stressing force is transferred. That pre-stressing force, the P, is transferred to the concrete through this anchorage device. So here the anchorage system will be provided, and that system will transfer the pre-stressing force to the concrete. So that is nothing but the anchorage zone or end block. It is also called as anchorage zone or end block. So in other way, if I want to explain, in post tension members, the pre-stressing wires are introduced in the cable holes. What will happen in post tension beams? The pre-stressing force is introduced. The pre-stressing force is introduced through by providing wires or cables into the ducts which are pre-formed into the concrete, because ducts are already provided into the concrete, just you have to pass the cable. Then stressed, the cables were passed and stretched, okay, and anchored at the face, and it will be anchored at the face. क्या होगा यहाँ पे, केबल को डक्ट से पास किया जाएगा, उसको स्ट्रेच किया जाएगा, then it will be anchored at the ends. Then what will happen? As a result of this, large force concentrated over relatively small area. तो यहाँ पे क्या हो रहा है, this bearing plate is bear the load. Whatever the concentrating force is transferred, that force has to bear by this bearing plate, and this bearing plate will transfer the force into the internal part. तो उसके बाद क्या होगा, here there will be large concentrated force developed. यहाँ पे क्या होगा, we can imagine that there will be large concentrated forces developed, okay, and it will be for very small area, because it will be very for small area, okay, are applied at the end block. So understood? I will repeat once again. The pre-stressing wires are introduced in the cable holes which is pre-formed into the members, and then stretched. The cables will be stretched and it will be anchored at the ends. The cables will be anchored at the ends. Then what will happen? As a result of this, large forces, when the cable is anchored, the large forces concentrated over small area and applied to the end block. So it will be applied to the end block. So therefore whatever the stresses are transferred, we have to do the special treatment for that, okay, we have to do the special treatment for that, okay. Yes, I can show you the one more image here. You can see again the beam here, we have a tendon and the pre-stressing force, okay. So here is a local zone. Local zone means anchorage zone, where the cable is anchored, and we can see this is a bearing plate. We can see this is a bearing plate. It's a bearing plate, and over that bearing plate the force is applied. And that force will be transferred to the general zone. General zone is nothing but the concrete section. तो यहाँ पे क्या होगा, in this portion the large stresses are developed, okay, the large stresses are developed, and we have to treat those stresses. We have to give special treatment or the additional reinforcement we need to design at this zone, so which is called as anchorage zone or end block. It is nothing but the anchorage zone or end block. So I can show you the stresses developed in the concrete section, how the stresses will develop. So what will happen here? So whatever the stresses developed in the anchorage zone are in tensile nature over a large length, and since concrete is weak in tension, adequate reinforcement should be provided to resist the tension, okay. So I will just explain how the forces will transfer, okay. So you can see here again we have the forces which is transferred over this bearing plate. So this is again a bearing plate, we can see this is a bearing plate, okay. Then the forces are transferred through this bearing plate to the concrete section. Now you can see the forces are in this direction, the convex and concave flow of the force, and even we can see the forces are in this direction also. So there are two forces are developed here. One is tensile stresses. So these are nothing but the tensile stresses, and these are nothing but the compressive stresses, okay. These are compressive stresses. तो इसके वजह से क्या होगा, when the force is applied at the end, so that force will try to develop the tension into the end block, try to develop the tensile stresses try to develop the tensile stresses in concrete. And we know that the concrete is when the tensile stresses are developed like this, try to elongate, try to pull out the concrete, try to pull out the concrete, try to pull out the concrete. So as we know that concrete is weak in tension, so to avoid the failure at the end block, we have to design a special reinforcement for that, or we have to design a adequate reinforcement which is provided at the end of the section where the anchorage is provided to resist the tensile stresses. Okay, understood. So this is regarding how the force will travel into the concrete at the end zone. Okay, so I can show you the one more sketch how the forces will transfer. Okay, yes, here you can see, here we can see. So here it's a small part of the beam section, how the stresses will flow into the concrete due to the prestressing force. Okay, so I'll just explain the components again. यहाँ पे देखो, we have the bearing plate. So this is the bearing plate again. So why it is called as bearing plate? It will bear the load and transfer to the concrete. So that's why it is called the bearing, bear the load and transfer to the plate. So that's why it is called as a bearing plate. Okay, and these are the prestressing force. These are the prestressing force. Okay, तो अभी यहाँ पे क्या हो रहा है? The cable is stretched. See, this is the end block or the anchorage zone design is specially done only in case of post tension beam sections. I am repeating once again, the end block or the anchorage zone design is done only in post tension beam sections. Okay, so what will happen? The cable will be stretched through the duct which is pre-formed in the section, and the cable will be passed through the duct and it will be stretched. It will be stretched. Stretch होने के बाद क्या होगा? Ultimately the cable will be anchored by using different anchorage devices. There are n number of anchorage devices to anchor the cable. Okay, the cable will be anchored at the end and they will provide a bearing plate. So that bearing plate will transfer the force, the prestressing force into the concrete, and we can see these are the flow of the forces or the flow of the stress developed into the concrete due to the prestressing force. Okay, so we can see these are the longitudinal stresses developed, the flow of the longitudinal stresses, and this will also try to develop the tensile stresses like this. This will also try to develop the tensile stresses like this, like this. Like this. So what will happen? So tension, again this side also tension, tension, tension. So what will happen because of this tensile stresses? The concrete will try to move out from the section because of the tension, or it will crack, or it will burst. Okay, so to avoid that we have to design, because concrete is weak in tension, so we have to concentrate more on these forces. These forces are compression. So compression we don't have that much problem because concrete is strong in compression. So we have to concentrate more on these forces, that is transverse forces. Okay, transverse stresses. So what is that? The transverse stresses developed, the transverse. So these are the longitudinal stresses. इनको बोलते हैं जो black line है ना, these are the longitudinal stresses and these are the transverse stresses. So what it is called? The transverse stresses developed in the anchorage zone are tensile. Though these are the transverse stresses are tensile, and since concrete is weak in tension, our concrete is weak in tension, adequate reinforcement should be provided to resist this tension. So in the anchorage zone, at the anchorage zone, whatever the tensile stresses developed, for those stresses we have to design the adequate reinforcement. We have to design the special reinforcement in the end zone or in the end block to resist those tensile stresses or to resist the tension. So that is nothing but design of end block or design of anchorage zone. Okay. So here how the curvature of the forces will flow here. So here the curvature of the forces being convex towards the center line, you can see it is being convex, it is being convex towards the center line of the block, induced compressive stresses in zone A. So यहाँ पे क्या होगा, this will be like convex. So at zone A you can see this is zone A, so it will induce the compressive stresses at zone A. Then later again in zone B we can see the zone B here. In zone B the curvature is reversed. यहाँ पे देखो क्या हो रहा है अभी, it was convex, now it will become reverse. The curvature is reverse in direction and the forces tends to deflect outwards. यहाँ पे देखो forces क्या हो रहा है अभी at this particular section, if I consider the forces are like this, and here at particular section, that is at zone B, the forces are try to deflect. The forces are try to deflect. So what is happening here? I'll repeat once again. In zone B, the curvature is reversed. The curvature is reversed in direction, and the forces tends to deflect. Forces tends to deflect outwards. Deflect outwards. Okay, separating from each other. So here if you see the spacing between the forces, this is very small. The spacing between the forces is very small, but here they are trying to deflect and bifurcate. So they are separating to each other. They are trying to separate to each other. Okay. So then what will happen? When they try to separate, they try to develop the tensile stresses also. देखो यहाँ पे कम है तो यहाँ पे जब वो try to separate तो क्या करेगा वो? Try to push the surrounding concrete. Okay. So try to develop the tensile stresses. Next in zone C, what is happening in zone C? In zone C, the forces are straight. अभी यहाँ पे देखोगे the all forces are straight. In zone C, the all forces are straight and parallel. Straight and parallel. If you see the gap, it is like parallel. The forces are traveling like parallel. The forces straight and parallel, so that no transverse stresses are induced. अभी यहाँ पे in zone B what was happening? They were trying to deflect. So deflect, during deflection what they tries to do? They try to push the concrete. When they tries to deflect from each other, try to push the concrete. So that time the tensile stresses were developed. But here what is happening? Because the forces are straight and parallel, no transverse stresses are induced. So this is very important. At zone C, there are no transverse stresses or the tensile stresses are induced. Only longitudinal stresses develop in this zone. So in इस zone में क्या हो रहा है? Only longitudinal stresses are developed. This is very interesting and very important. Zone A में क्या हो रहा है? There is only compression because immediate the force is applied. तो यहाँ पे क्या होगा? Only compression develop करेगा. Okay. When it moves from zone A to zone B, तो try to change the direction or try to deflect. When they try to deflect, they try to push the surrounding material or concrete. तो push करेगा मतलब it will try to develop the tensile stresses in the concrete at the particular zone B. Okay. And after zone B, the force, the direction or the travel like straight and parallel to each other. So because of that, when they are traveling straight and parallel, there will be no transverse stresses or tensile stresses. Only they will develop the longitudinal stresses which develop compression. अभी ये क्या करेंगे? The longitudinal stresses will develop only compression, and compression no problem because concrete is strong in compression. Okay. And we can see the component of the anchorage zone is y0 and y0. तो इसका जो traveling that the zone is 2 times y0. Always it will be 2 times y0. Means we have to give the special treatment for this zone, that is 2 times y0, and this is then y0, y0. This is equal to this, means 2 times y0, 2 times y0. Okay. So this is regarding, and when it is for single anchor plate. अगर ये double anchor plate होगा तो it will become like this. Okay, it will become like this. Again you can see it is like the forces are, the flow of force is deflected here. Up to this it was deflected, from this it is again straight parallel. So here we can there will be only longitudinal stresses which develop compression, but इस case में क्या होगा, try to deflect, so they will develop the tensile stresses like this, like this. Okay, so because of that what will happen, we have to give some special arrangement or adequate reinforcement to resist this anchorage zone. Okay, so this is regarding how the anchorage zone is important in post tension beam sections. Okay, and how the tensile stresses and or the transverse stresses and the longitudinal stresses are developed in the end of the section where the anchorage system is provided in post tension beam section. Okay, so I can show you the one more diagram here. Okay, so I think all three sketches are visible here. Okay, यहाँ पे देखो क्या हो रहा है. फर्स्ट केस देखो, so this is first case, second case, third case. The distribution of forces, यहाँ पे देखो फर्स्ट केस में क्या हो रहा है. It is very near to the end block or the bearing plate. तो यहाँ पे देखो the force concentration is more here, the stress concentration is more because this is very near to the bearing plate or the anchorage system. तो यहाँ पे क्या होगा, always the stress concentration will be more. So because of it is called as spalling tension, and here we have the more tensile stresses and the flow of force is also very high. Okay, that is called as bursting tension. So that will try to burst the concrete. So that's what is called as bursting tension. Okay, then if I move to zone 2, okay, zone 2 is, see here it is zone 1, zone 2 is little away from here. तो यहाँ पे क्या हो रहा है देखो, tension is there but it is the magnitude of the tensile stress is very less compared to first zone. यहाँ पे देखो the stress distribution कैसे है और यहाँ पे देखो stress distribution कैसे है. There is no stresses are here, stresses are there but the magnitude of the stresses is very less compared to zone 1 and zone 1. Now if I go to zone 3, तो इस केस में देखो क्या हो रहा है फिर से, there is the forces, the tensile stresses are like nil, only we can have the compressive zone. यहाँ पे देखो, यहाँ पे compression थोड़ा है लेकिन tension ज़्यादा है. You can see this shaded part is less than this, but if you come here the compression is little bit more than this. This shaded part is compression. Okay, and the tension is less. Compression ज़्यादा है, tension कम है. But again if I go to zone 3 में देखो again compression is increase and tension is decrease compared to 1 and 2, zone 1 and zone 2. मतलब क्या हो रहा है यहाँ पे, as you move away from the anchorage device, the tension is reducing, that there is no transverse stresses develop into the concrete but compression stresses are developed. यहाँ पे देखो, if you compare this and this, okay, the quantity or the magnitude of the compression stresses are more, the longitudinal stresses are more. For that we don't have any problem because our concrete is strong in compression, but we have to concentrate on this. So we have to give special treatment here in this zone compared to 2 and 3. We have to give special treatment or we have to design adequate reinforcement to resist this, that is bursting tension. अगर यहाँ पे if you are not taking care of this, तो what will happen, it will burst. So that's why it is called as bursting. So it will try to burst the concrete because of the tension, it will try to burst the concrete. Okay, understood? So that's why we have to give special treatment or we have to make a special arrangement at the anchorage zone or end block in post tension beams. So this is regarding today's that is the importance of anchorage zone or anchorage zone stresses in post tension beams. Okay, thank you.